Okay, next up is question 8. Part A says find the point or points of intersection between the line described by these parametric equations and the cylinder described by the equation y squared plus z squared is equal to 4. All right, well, cylinder is the cylinder of radius 2, and the x-axis is the axis of this cylinder. And then here I've drawn this line in purple. All right, now to find a point of intersection, well, the key idea there is that at a point of intersection, we are on the cylinder as well as on the line. So what we're going to do is take the coordinates on the line and substitute them into the equation for the cylinder and solve the resulting equation for t. Okay, so we do that here. The cylinder equation, y squared plus z squared is equal to 4, becomes y squared, so 4 plus 2t quantity squared, plus z squared, that'd be 2 squared, is equal to 4. And now I have a 4 on the left side and on the right, so those drop out, and I have 4 plus 2t quantity squared is equal to 0. Taking square roots gives us that 4 plus 2t is equal to 0, and so t is equal to negative 2. Now to find the corresponding point of intersection, plug negative 2 in for t into the coordinate functions for the line. So we get that x is 5, y is 0, and z is 2. Okay, and so in fact here, this line intersects the cylinder at just a single point, okay, at this 1.502. One thing also to note here, since the z coordinate of the line is constant 2, that implies that this line, in fact, is parallel to the xy plane. Okay, great. So now moving on to part B, it says find the point or points of intersection between the line described by this vector function r of t, which is t plus 1i plus 2tj plus 2t minus 1k, and the sphere described by the equation x minus 1 quantity squared plus y squared plus z plus 1 quantity squared is equal to 9. Okay, so I have a sphere here, and here's our line. And so just as we did in part A, at a point of intersection, right, we have to be on the sphere as well as on the line. So we're going to take the coordinate functions for the line and substitute them in to the sphere equation, solve the resulting equation for t, and that will give rise to the points of intersection. So here is our sphere equation. So I'm going to set x equal to t plus 1, y equal to 2t, and z equal to 2t minus 1. So this all simplifies to t squared, these ones drop out, plus 4t squared, plus another 4t squared, these ones drop out. That's equal to 9. And on the left side we have 9t squared, so we have that 9t squared is equal to 9, and so t squared is equal to 1. Taking square roots, we find that t is equal to plus or minus 1. So we in fact get 2 points of intersection. Okay, so to find the coordinates, we want to plug t equals 1 into the coordinate functions for the line, and then plug t equals negative 1 into the coordinate functions for the line. And our 2 points of intersection are 0, negative 2, negative 3, and 2, 2, 1. Now the way I've drawn this picture here, it looks like this line, in fact, passes through the center of the sphere, which actually is the case. Notice if I take the average of the x-coordinates of these 2 points of intersection, okay, so 0 plus 2 divided by 2, well, that's 1. Take the average of the y-coordinates, I get 0. Take the average of the z-coordinates, I get negative 1, okay? Put another way, the center of the sphere is the midpoint of these 2 points of intersection. Okay, so we refer to these points that are on opposite sides of the sphere as antipodal points for the sphere. All right, well, in any event, that does it for this question, and I will see you in the next video. Thanks so much.